Okay, so we'll start with number 1. Here we have, they give us the symbol, and they put a 2 here, which you will never ever see after the first few problems there, okay? Because normally that's something that the lazy mathematician does not write. The lazy mathematician would normally write it this way. If it's a 2, it's kind of like one of those invisible ones that the lazy mathematician never writes. It's like most of the time we deal with square roots, so they're just not going to write square root on it. They're just going to put it like I have written it here on the right, okay? Now, they've got the parts of this labeled, and honestly, I never remember what these, I know that this right here is the radical sign, okay? So when they point to that little, the little actually boxed part of it, and I think on your book it's actually pointing up here at it, that's just the radical sign if you want to fill that in. The number that's out in front, which remember, if it's not there, you assume it's a 2, that you're taking a square root. This number right here, I'll write in a different color. That's called the index, and I'll circle it, okay? And the number under here is called the radicand, that I'm writing in green. I circled it in green. It's called the radicand. Most of the time, I never use index and radicand. You know, I'll say, oh, it's the square root. It's the number under the square root. You might see it in a book, but most of the time teachers don't think to use those mathy terms. And then the radical is actually just the actual thing that looks like that, okay? We call anytime you see like a cube root, square root, fourth root, fifth root, we usually call those radicals. We just say, look under the radical, and they're talking about, you know, the fact that it is one of those root type things. And then you look out front to see if there's not a number there, it's a square root. If there is a number there, that's the root you're taking, okay? All right. Okay, everybody got that down? The one, and it's in your book, so you could actually, if you're writing in your book, you could highlight it, but most of you guys aren't writing in your books, right? You're saving them, okay? Analogy to you that I use sometimes to help students kind of get this. And y'all may not even need it. Y'all might go, yeah, it's 4. I don't need to any other little story to help me with this. But sometimes when we get to harder things and it gets a little more confusing, you can kind of come back to this story. Under the radical, if I want to get a number out of it, I have to have 2 copies of the same thing. On all of these today, they're perfect squares. So they're trying to get us to remember our perfect squares. But when things get harder, we could even come over here and factor this out. We might know 4 times 4 is 16. That's what we're trying to do today, is look at perfect squares, what a perfect square is. But another way to do it, if you ever get stuck, is to factor the number with a prime factor tree. Okay, so this is what we're going to do when we don't notice, like we go, I don't know what number that is. I don't remember that square. I could write that as its prime factors all together. 2 times 2 times 2 times 2 is another way that I could do this if I don't know what the square root of a number is, because like some of these numbers get kind of big and we might not remember them. Now, if you think about it, you're looking for 2 of a kind. When you see 2 of a kind, you get to take that number out front, but it's one pair, okay? We're looking for pairs of numbers. There's a pair of 2, so I circle it, I put the 2 out front, and I don't rewrite it under the radical. But oh, there was another pair of 2's, right? So that pair can come out. There was already a 2 out front. That pair of 2's is really the square root of 4, right? And the square root of 4 is 2, so I could, just say, oh, square root of 4 is 2. There's another 2 in there. And there's nothing under the radical, so I don't need it anymore. And 2 times 2 is 4. That's a long way to do that problem, but if you get a number that you don't recognize, you could kind of go through that way of thinking. And let me tell you a story that you can do, too, with this. Let's say when you have a square root radical, we're going to call this the square root dance. Everybody's in the house and they want to go to the square root dance, okay? To go to the square root dance, you have to have a matching partner, okay? And when you go, you get to go out of the house and go to the dance, but you have to go as a couple. The 2's go, oh, look, I found somebody that looks just like me. I get to go to the square root dance. So they get to come out as a couple, okay? The square root of 4 is 2, right? It makes sense. But this is just a story for when you get stuck. Now, there's another pair of 2's in there that match up, and they go, oh, good, we get to go to the square root dance. So they come out as a couple here, and nobody's left under the radical, so we don't need it anymore. And 2 times 2 is 4. Or you could just say the square root of 16 is 4. It's always easier if you know the perfect square, but sometimes we get stuck and we don't know it. So you don't have to make these harder than they are, but I'm telling you this because we're going to do some harder problems eventually, okay? Okay, yeah, well, let's get to that. Let's look at number 8 first. And we kind of go in a certain order here. All right, if I have on number 8, the negative square root of 64. Here's what they're telling me. First of all, what is the square root of 64? 8. 8 times 8 is 64, right? But isn't also negative 8 times negative 8 64? And aren't that's 2 of a kind also, isn't it? Those 2 look just alike also. They're the same number. So when we take square roots, when we're in Algebra 2, and mostly even at the end of Algebra 1 and we take square roots, we have to consider both the positive and the negative root because there's 2 numbers that fit that, right? And if I'm trying to find solutions to an equation, I need to consider that there really are 2 answers. Let me show you what this looks like just so this isn't so abstract here. What if I had x squared is equal to 64 and I wanted to know the answer to that equation? If I want to get x by itself, the opposite of squaring is square rooting. That's how we're going to use this eventually when we get to equations. If I square root x squared, it's just x, right? Since x times x is x squared. But if I square root of 64, don't I have 2 things that would work? There's this positive 8 here, but there's also a negative 8. So normally when you get into Algebra 1, later part of that year, and then in Algebra 2, you would write there's a positive 8 and there's a negative 8. And that's the short way for writing x equal 8, x equal negative 8, okay? So it's just the lazy mathematician way of saying there's 2 answers, positive 8 and negative 8, and we don't want to hurt our little hands and have to write that 8 2 times, so we're just going to write it that way. So it makes more sense where this comes from if you know how you're going to use it eventually. And this is how we're going to use it eventually to solve little equations. So like on number 8, when they put the negative out front, they're telling you they want negative 8. Okay? And on number 9, when they've got plus square root of 25, they're telling you they want positive 5. If they don't put anything at all, we really should always write plus and minus like we did down here if they don't put anything at all. If they put a plus sign, they're telling us just do the positive one. If you look at number 11, negative square root of 100, what do they want me to write here, you think? Negative 10. They're saying don't worry about plus or minus, just take the negative one. Back on in case Kaylee's listening. Okay, so 10 plus or minus square root of 4, they want you to write plus or minus 2. Okay? If you notice in this lesson, they've given you all perfect squares. We're going to do some probably Thursday that aren't perfect squares. So we'll see what to do if they don't put a perfect square under the bracket there. Look at number 16. What are you supposed to do with 16, you think? Oh, 16 is square root of 1, okay? So square root of 1 is plus or minus 1. The answer key says 1. Really, if they don't put anything, I probably should put plus or minus 1. If you look at the answer key, they've just put 1. So in this book, if you're trying to think, how is the answer key working? Because it's probably going to confuse you when you check your answers. If they put a plus or minus out front, they want you to put a plus or minus in the answer. Like on 16, if they just put square root of 1, they just want you to put positive 1. You can put plus or minus 1 if you want to. That would be a good way to develop some good habits for Algebra 1 and Algebra 2 to just put plus or minus on it if they don't put anything out front. If you you know how sometimes you just need to get good habits so that later on you don't forget to do things when it really is going to count? It would be a good idea to do that here. So if you ever see that they just put 1 in the answer key and you put plus or minus 1, I would not, don't mark that as missed. You actually did the right thing, okay? So if you get confused by the answer key, I definitely understand in this case because I'm looking at it going, oh, how are they? Peyton?
Can we look at number 18?
Sure, 18. Yes, this is what I wanted to get to next. 18 is plus or minus, so they're telling me they want both. Normally books won't tell you, you just have to know to do both, okay? So they're trying to, so I know because they wrote that, they want me to put that on my answer. When you have a fraction under a radical, it looks a little scary, but it's really not. You can divide that fraction up into the square root of 9 over the square root of 16. You can give them each their own radical. What's the square root of 9 on top? 3. What's the square root of 16 on bottom? 4. See, that wasn't bad, was it? So one of the rules of radicals is if they put something under the radical as a fraction, you can split it up and give it its own radical. Sometimes it's more helpful to put them back together. We're going to see that too. Jaden?
Can you do number 22?
Okay, 22's on, okay, these, we're not going to use the table of squares and all this stuff, so you're going to have a hard time checking your work with this unless we do these together in class, because we're not going to do that. That's not normally what we do. So I'm going to change the directions on this 22 to 36. So we're just going to reduce, we're going to simplify the radical, because this is what I really need you to learn, and some of the past classes kind of got by without learning it before I got here. And it's really giving them a hard time now in some of their work in geometry. So the square root of 22, 22 is the square root of 52. Now that's not a perfect square, is it? So I'm going to show you what to do. Do you remember how I told you that when the problems got harder, we could come off to the side and we could prime factor this number, right? So 52, it ends in an even number. So I know 2 divides into 52. 26 times, right? We could sit and do the division if we had to. Every time I see a prime number, let's circle it just so we don't forget that we need to write that in a minute. Because what we're going to do is rewrite 52 in terms of all of its prime numbers, okay? We're just going to rewrite it. Wouldn't it be equal to all its prime numbers multiplied together? So we're just going to replace it with that so we can see, how to simplify it. Now 26 is still an even number, so I know I can still divide it by 2. 2 and 13, okay? Is 13's prime, right? I accidentally circled it. I was going to ask you. 13's prime. I've got all prime numbers now, right? So I'm going to come over here and I'm going to take those prime numbers and I'm going to write them down under the radical. And then I'm going to look for pairs of numbers, because doesn't it take 2 of something to make a square? Okay? So who gets to get out of the radical? Huh? You have a pair of 2's. That's like, if you think about it, 2 times 2 is 4, right? The square root of 4 is 2 outside the radical, right? Now, the little story I told you went like this, if you get confused. We got square root dance. You got to have a matching partner to go to the square root dance. You got to have 2 matching numbers. 2's match. They get to go to the square root dance. They come out as a couple. The square root of 4 is 2, right? And then they're not under the radical anymore, so don't put them back under the radical. Does poor little 13 get to get out? No, he gets left at home alone. He does not get to go to the square root dance. That is simplified, okay? That's what we're going to do. We are not going to put all these decimals down. If I want the decimal approximation for a square root, I'll get my calculator out and hit the square root button, right? In the olden days, when I was growing up, you didn't have these calculators and you actually had to go look at a square root table and write that down. But that's like so long ago, there's no point for us to do that now. We would never, ever, ever do that outside of this class. So when you get a calculator, if you ever need to know what that number is, you can hit it and find out. But most of the time, we don't use decimals anyway. We use this kind of stuff in algebra.